3, 2, 1. MDS, we have ignition, we have a liftoff.
The roll program is in on time.
NASA says that Voyager 1 has become the first man-made object to reach interstellar space.
Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
This is the first time we have begin to explore this new region of space, interstellar space.
Envision a quiet wanderer floating solo in the immense void, farther than any man-made item has ever reached. Billions of kilometers away from home, beyond the reach of our sun's light, a small spacecraft continues to send faint signals back to Earth. These whispers hold tales of bizarre realms, tumultuous tempests, extraterrestrial forces, and the enigmatic boundary where our solar system concludes and the galaxy commences. Inaugurated over 40 years ago, the Voyager missions were not intended to endure for such an extended period. Despite all challenges, these twin pioneers have surpassed their creators, surpassed their fates, and revealed mysteries that transformed our comprehension of the universe. At the boundary of interstellar space, Voyager discovered phenomena previously deemed impossible, unseen barriers of hydrogen, the eerie resonance of the galaxy itself, and hints that confront all our understanding of where space genuinely starts. This is more than merely the tale of two devices, it's the tale of mankind's most significant jump into the unfamiliar and the astonishing revelations that awaited us in the endless darkness. This is the unspoken account of Voyager's astonishing findings at the border of the solar system. It was the year 1977. Humankind was still discovering how to aspire towards the stars. Only 8 years before, we had set foot on the moon, but beyond that stretched a wide, unexplored frontier. NASA envisioned a goal to dispatch a messenger further than ever achieved, a spacecraft capable of reaching the distant planets, Jupiter, Saturn, Uranus, Neptune, and possibly, just possibly, going past them. Yet, there was a single issue. These worlds were unimaginably distant from each other. Then arrived an extraordinary chance that happens once every 176 years. The planets were ideally positioned for one spacecraft to slingshot from one to another, utilizing gravity as an interstellar route. Thus, two robotic trailblazers emerged, Voyager 1 and Voyager 2, twin adventurers designed to transport humanity's inquisitiveness into the vast unknown. All were outfitted with cameras, sensors, and tools meant to uncover the secrets of the massive planets. However, NASA engineers included something remarkable, a message, a golden record featuring Earth's sounds, music, laughter, messages in 55 languages, and a human heartbeat. A time capsule in the event that anyone or anything ever discovers it. With the rockets igniting, the Voyagers departed from our planet. Few could have envisioned that years later, they would still be out there, navigating the emptiness, discovering mysteries that no one had previously encountered. With their golden records aboard and their instruments armed, the twin Voyagers began their journey into the cosmic deep, a voyage that would soon redefine humanity's place in the solar system. Jupiter. The giant awakes. Voyager 1 arrived at Jupiter in 1979, and its discoveries amazed everyone. Through its gaze, Earth perceived Jupiter as never seen before, a realm of tumultuous energy where tempests surged greater than our whole world. The Great Red Spot, previously regarded as tranquil and stationary, was uncovered as a hurricane centuries old, swirling with incredible power. However, Jupiter was more than merely a gas giant. Its satellites were animated. Voyager's cameras recorded explosive eruptions on Io, the most volcanically active entity in the solar system. Streams of liquid sulfur ascended hundreds of kilometers into the atmosphere, coloring the void with bands of yellow and red. Nobody had ever envisioned that a moon could possess geological activity. And then came Europa, a slick, fractured ice layer suggesting a large ocean below. Might it conceal existence? Voyager couldn't respond, yet it raised a question that continues to motivate scientists now. Voyager revealed that even moons, previously believed to be frozen, barren stones, could be realms of fire and water. Saturn, the ringed mystery. After 2 years, Voyager 1 arrived at Saturn. As it drew near, the gas giant's golden rings glistened like a celestial halo, bouncing sunlight in ripples of soft flame. However, Voyager discovered that the rings were not solid. Rather, they consisted of innumerable ice particles, each moving in flawless synchronization. The spacecraft found new moons, small shepherds that shaped the rings' fragile borders. At Saturn's northern pole, Voyager discovered an astonishing phenomenon. An enormous, perfectly geometric hexagonal storm continuously rotating in the planet's atmosphere. How is it possible for nature to create such an exact form? Years later, it continues to be one of Saturn's biggest enigmas. Then arrived Titan, Saturn's biggest moon. Voyager's equipment identified a dense, misty atmosphere, the sole moon in the solar system that has one. It was plentiful in nitrogen and likely abundant in organic compounds, the foundations of life. Under its orange clouds could be oceans of methane and ethane. To scientists, it seemed as if Voyager had caught a glimpse of an early Earth preserved in time. When it departed from Saturn, Voyager revealed a universe that was much more intricate and stunning than we had ever imagined. Uranus, the tilted enigma. As Voyager 1 raced towards interstellar space, Voyager 2 proceeded with the Grand Tour, the sole spacecraft to have explored Uranus and Neptune. In 1986, it reached Uranus, a light blue-green sphere spinning through space horizontally. Uranus's unusual tilt of nearly 98 degrees has confused researchers. Its magnetic field was also extremely off-center, angled and displaced significantly from the planet's core. Voyager 2 discovered delicate rings, 11 tiny moons, and temperatures lower than any other place in the solar system. It was a realm of oddity, silent, far off, and enigmatic. However, Voyager 2's findings were just beginning. Neptune, the blue giant. In 1989, following 12 years of exploration, Voyager 2 arrived at its ultimate planetary stop, Neptune. What it witnessed there surpassed expectations. Even though it was located far from the Sun, Neptune was a planet of turmoil. Voyager took pictures of the Great Dark Spot, a colossal storm nearly the size of Earth, twisting through clouds of methane. Winds screamed at velocities exceeding 2,000 kilometers per hour, the quickest ever noted in the solar system. Triton, Neptune's largest moon, showcased geysers of nitrogen gas bursting from its icy surface, indicating an evolving, active world. Triton circled Neptune in the reverse direction of the planet's rotation, indicating it might be a captured body, possibly an old world taken from the Kuiper Belt. As Voyager 2 left Neptune, it aimed its cameras back for a final view. In the dim light, the faraway planet glimmered like a blue gem in the void, a quiet goodbye to the final of the Titans. Within merely a few years, the Voyagers had transformed the textbooks of planetary science. They uncovered volcanoes in places thought to be safe, oceans previously unnoticed, and storms that defied belief. Worlds previously considered barren now buzzed with intrigue and activity. Every interaction revealed a glimpse into the incredible variety of our solar system. Yet, as the final images were sent back home, a fresh question started to emerge among both scientists and dreamers. What exists beyond? Beyond the domain of planets and satellites, there existed a tremendous unseen boundary, the farthest limit of the Sun's impact, a location where the known breezes of our solar system yield to the unexplored expanse of interstellar space. Voyager's upcoming voyage would not only discover new planets, it would venture into an unfamiliar type of space, a limit no device had ever surpassed previously. The edge of the solar system. Once Neptune receded from view, Voyager's cameras ceased functioning. Its main mission was complete, but its adventure had only just started. For the majority of spacecraft, this would signify the conclusion. However, Voyager stood apart. It was designed to endure, to continue functioning long beyond its intended mission, fueled by a tiny nuclear core that would pulse for years in the chill. Its new objective was much grander, to discover the outer limits of our Sun's influence. What exactly is the edge of the solar system? Our sun serves not only as a source of light and heat, but also as a cosmic power generator. It continuously releases a flow of charged particles known as the solar wind. These particles create a vast bubble around the sun called the heliosphere, an unseen barrier that safeguards every planet within it from the severe radiation of interstellar space. At the farthest edge of this bubble is a limit, the heliopause. Within it, the solar wind prevails. Beyond it exists the interstellar medium, the area between the stars, filled with dust, gas, and ancient cosmic radiation. It's the point at which the sun's reach stops and the galaxy starts. However, no one had ever witnessed it. Nobody had an idea of its location. Voyager was on the verge of discovering a journey through the twilight zone. As Voyager 1 moved further from the sun, the signals it transmitted became weaker, dim echoes journeying over 18 billion kilometers through the emptiness. A single message took more than 17 hours to arrive on Earth. A single message took more than 17 hours to arrive on Earth, while another 17 hours were needed to send a response. Engineers at NASA's Deep Space Network struggled to hear, utilizing large antennas to detect the diminishing signal of a probe sent out prior to the birth of many of them. In this remote area, the heliosheath, the solar wind, decelerated and interacted with the sparse gas of interstellar space. It was a tumultuous frontier, a celestial dusk region where the recognizable blurred into the unfamiliar. After that, unusual events started occurring. Voyager's instruments observed abrupt increases in cosmic rays. Billions of kilometers distant, Voyager glides on, quiet, relentless, everlasting, not merely a traveler of worlds, but a representative among the cosmos. Shocking discoveries beyond the edge. As Voyager 1 passed the heliopause, humanity did so alongside it. For the first time, a device constructed by humans ventured into the expanse between the stars, an area devoid of sunlight, where neither planet nor magnetic field could offer immunity. What it discovered there shocked even the most cautious researchers. 1. The sound of the galaxy. At first, the data seemed almost silent, background noise, faint static from a dying probe. But when scientists at NASA's Jet Propulsion Laboratory translated the plasma wave readings into sound, something eerie emerged, a low, ghostly hum rising and falling like distant music. They realized Voyager was detecting vibrations in interstellar plasma, the charged gas that fills the void between stars. Each wave was caused by shock fronts from ancient solar eruptions colliding with the surrounding medium. To human ears, it sounded like the universe itself was breathing. This wasn't an ordinary sound, of course, there's no air out there. But these oscillations revealed density, temperature, and rhythm in what had once been thought to be empty space. The galaxy, Voyager showed, wasn't silent at all. It sang. When researchers sped up the audio, the tones formed a cosmic symphony, slow pulses and trembling frequencies that told a story 18 billion kilometers away. Each note represented the heartbeat of a living, shifting interstellar ocean. For the first time, we could hear beyond the solar system. 2. The magnetic field shock. If the heliopause were simply a wall where the sun's wind stops, scientists expected the magnetic field outside to change direction completely. But Voyager's magnetometer told a different story. The field beyond the boundary was stronger than expected and oddly aligned, almost parallel to the one inside the heliosphere. It was as if the two regions were not separated by a clean break, but stitched together by invisible threads. This discovery baffled researchers. Some proposed that the sun's magnetic field might be entangled with the galaxy's own magnetic web, twisting and reconnecting in ways never before imagined. Some proposed that Voyager had not entered completely open space, but rather a transitional zone, a magnetic cocoon protecting the solar system like a cosmic membrane. The consequence was tremendous. Our solar system may not finish suddenly, but instead slowly merge into the interstellar medium, intertwining light and darkness in a chaotic boundary spanning tens of millions of kilometers. The data from Voyager compelled scientists to revise the boundaries of our sun's domain. We were residing in a magnetic bubble floating in a galactic ocean, and Voyager had just grazed its radiant surface. Its crew on Earth, many of whom weren't even alive when it was launched, continued to listen, continued to observe, continued to anticipate. Each distant sound resembled a pulse in the shadows. In 2012, an extraordinary event occurred. crossing the cosmic shoreline. In late August of that year, Voyager 1 noted a significant shift. The count of galactic cosmic rays sharply increased, whereas the flow of solar particles surrounding it almost disappeared. The sun's shielding bubble was over. The plasma beyond was thicker, cooler, clearly interstellar. For weeks, researchers discussed the information. Some believed it was yet another false alarm. Some thought that the unimaginable had occurred. Finally, a conclusive piece of evidence came in. The plasma wave instrument on Voyager identified a subtle vibration, the oscillation of ionized gas surrounding it. By analyzing its frequency, scientists were able to determine precisely the location of the spacecraft. What they discovered rendered them unable to speak. The noise was unique, not the soft murmur of the solar breeze, but the rich, echoing murmur of the galaxy itself. After 35 years of journeying, Voyager 1 had achieved it. It had exited the solar system. The declaration, issued by NASA in September 2013, created a stir globally. For the very first time in human history, a creation of our kind had reached interstellar space. From this point forward, Voyager would cease to orbit our sun. It would revolve around the Milky Way, and the lonely pioneer. Even at this moment, Voyager is still traveling outward at more than 17 kilometers per second, getting further away each instant. Its signals diminish yearly, its strength diminishing like the final spark of an extinguishing flame. Yet, it communicates, transmitting information from the farthest boundary ever attained. It informs us that the division between stars is not a distinct line, but a broad, fluctuating ocean, one teeming with waves, magnetic tempests, and unseen barriers of hydrogen. It reveals that the cosmos outside our sun is not vacant, but brimming with vitality and enigma. And far away, 3. The surge of cosmic rays. As Voyager ventured deeper, its detectors lit up with particles so energetic they could shred DNA and penetrate spacecraft walls. These were galactic cosmic rays, fragments of atoms accelerated by supernova explosions and black hole jets across the Milky Way. Inside the heliosphere, the sun's magnetic field had deflected many of them, keeping Earth safe. But outside, there was no shield. The intensity of cosmic rays doubled, confirming beyond any doubt that Voyager had entered a foreign realm. Each particle striking the spacecraft was a messenger from distant stars, some possibly born before our solar system existed. Voyager was being bombarded by the history of the galaxy itself. This realization changed more than astrophysics. It changed my perspective. Every atom, every molecule on Earth had once been shaped by the same cosmic violence that now surrounded Voyager. It reminded scientists that our solar system is not isolated, it is a tiny eddy in a vast, energetic storm. 4. The mysterious hydrogen wall. In 2018, data from both Voyager 1 and Voyager 2 revealed something extraordinary. A wall of hydrogen atoms pressed against the outer edge of the heliosphere. As the sun's wind slows and collides with the interstellar medium, it piles up interstellar hydrogen like waves against a ship's bow. Voyager's ultraviolet sensors detected this dense region, brighter and thicker than models had predicted. Some scientists called it the heliospheric wall, others the hydrogen wall. It was invisible to telescopes, but tangible to Voyager's instruments, a literal boundary where the breath of our sun met the galaxy's ancient winds. But there was something else. The wall seemed to move, pulsing with solar activity even from billions of kilometers away. It was as if the edge of the solar system was alive, flexing and shifting in response to the heartbeat of the sun. 5. Plasma density surprises. Voyager's plasma instrument kept detecting strange patterns. Instead of a smooth, uniform interstellar medium, it found dense pockets and empty voids regions where plasma behaved like waves in a stormy sea. These variations showed that the space between stars is neither tranquil nor consistent. It's chaotic, teeming with ripples from supernova explosions and magnetic tempests journeying for millennia. Voyager had arrived in a region where each measurement narrated tales of far-off disasters. Nonetheless, despite its outdated sensors, it charted the density of interstellar plasma more accurately than any previous mission ever. NASA researchers likened it to tossing a bottle into the sea and understanding the planet's tides based on its floating behavior. Voyager's faint data, measured in tiny voltage shifts, was rewriting the physics of interstellar space. 6. A second witness, Voyager 2. In November 2018, 41 years after launch, Voyager 2 followed its twin across the boundary. Despite being in a different direction, it confirmed almost every observation Voyager 1 had made. The plasma density jump, the drop in solar particles, the increase in cosmic rays, the same magnetic field orientation. This proved the phenomenon wasn't a fluke of direction or location. It was universal, the true signature of the solar system's edge. With 2 points of data separated by billions of kilometers, scientists could now begin to outline the actual shape of the heliosphere. Not a perfect sphere, but a distorted teardrop, flattened on one side by interstellar winds. Our solar system, it turned out, travels through the galaxy like a comet with a long magnetic tail streaming behind. Voyager 2's crossing also revealed a shocking detail. Just beyond the boundary, the plasma was hotter than expected, nearly 50,000 degrees C. Some unknown mechanism was transferring energy across the heliopause, perhaps through magnetic reconnection or turbulence. The Sun and the galaxy were not separate after all. They were in conversation. 7. The message in the data. Every byte of Voyager's transmission travels for more than 20 hours before reaching Earth, whispering across space at the speed of light. The signal is so faint that by the time it arrives, its power is less than that of a single snowflake hitting the ground. Yet within that whisper are revelations about the very structure of our cosmic neighborhood. NASA engineers often describe it as listening to the universe breathe through a straw. Each pulse, each rise in frequency or density carries secrets of the interstellar medium. But even as Voyager teaches us, it's slowly dying. In order to save energy, systems are being powered off, one test at a time. In the coming 10 years, the final instrument will cease operations, and the spacecraft will wander endlessly, its golden record faintly shining in the darkness. Nonetheless, its findings have transformed the understanding of cosmic geography. The heliosphere, previously just a theoretical bubble, is now charted. Interstellar space, which used to be mere fantasy, is now a quantifiable domain. And amid it all, Voyager keeps on journeying, a speck tinier than a particle of dust, carrying the narrative of humankind. 8. The awe of discovery. The impact of Voyager's discoveries was not only scientific, it was existential. We discovered that the division between our realm and the galaxy is delicate, permeable, and ever-changing. The energies and particles that influence planets, stars, and existence are perpetually interacting and transferring across the emptiness. The voyage of Voyager demonstrated that exploration focuses on inquiries rather than destinations. Each new reading, each anomaly, reminds us how little we truly know. It humbles us, yet inspires us. For in that faint signal, traveling from the edge of the sun's dominion, lies proof that curiosity can outlive generations. Somewhere beyond 23 billion kilometers, Voyager drifts in a realm where sunlight is just another star in the distance. Around it stretch the unseen magnetic tides of the Milky Way, the faint murmur of ancient starlight, the whispers of creation itself, and still, it listens. It listens for the heartbeat of the universe. The human legacy far beyond the warmth of our sun, beyond every planet, every comet, and every trace of human gravity, Voyager continues its eternal flight, a silent witness to the cosmos. Its cameras are long shut down, its sensors grow colder with each passing year. Yet it remains alive in the faintest sense, still whispering through the darkness, still reaching out to the only home it has ever known. Each time NASA's Deep Space Network catches a signal, weaker than the flicker of a candle seen from across the solar system, engineers pause, knowing they are hearing from a traveler more distant than any other in history. But Voyager carries more than instruments and data, it carries us. Bolted to its side is a small golden record, a time capsule of Earth. Etched into it are the sounds of rain, the laughter of children, the crash of ocean waves, the songs of Bach and Chuck Berry, greetings in 55 languages, and a mother's heartbeat. It is, quite literally, the voice of humanity, our message to the stars, a promise that we were here. Carl Sagan, one of Voyager's visionaries, once said, "The spacecraft will be encountered, and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Voyager is more than a probe, it is a mirror. In its long journey, we see the reflection of our own desire to explore, to know, to reach beyond the horizon simply because it's there. When future beings, human or otherwise, find it drifting among the stars, they will discover not just a machine, but a message from an ancient civilization that once looked up and wondered. Voyager is proof that even from one small world, something extraordinary can reach infinity. And as it sails through the endless night, untouched, unforgotten, it carries with it the legacy of all humankind, the echo of our curiosity, the pulse of our hope, and the eternal question that has driven us since the dawn of time. What lies beyond? Outro. Since its initial launch in 1977 to its present expedition through interstellar space, Voyager has taken us beyond what any human eye or mind could ever conceive. It has revealed realms of flames and frost, tempests greater than Earth, seas beneath icy surfaces, and magnetic energies crafting unseen designs throughout the universe. It has outlined the boundary of our sun's impact and tuned in to the subtle sound of the galaxy. Despite this, Voyager's most significant finding might not be scientific in nature. It serves as a reminder that humans can envision without boundaries, that even from a tiny planet, we can extend into the immensity of space and make a mark, no matter how small, in eternity. Its golden record shines brightly like a symbol of hope, transmitting our music, our voices, our narratives, way beyond the boundaries of our solar kin. Amidst the quiet void, Voyager glides, representing exploration, bravery, and the desire to comprehend the cosmos. The boundary of the solar system is no longer an enigma, yet beyond it exists an endless expanse, stars, nebulae, and cosmic oceans we have yet to explore. Voyager is a trailblazer, a communicator, and a reflection, revealing our potential when we have the courage to look upwards. And as it journeys into the uncharted, continuing to send messages across billions of kilometers, it imparts to us a straightforward, lasting truth. Discovery is limitless, wonder is boundless, and the cosmos is awaiting. Voyager continues its journey, bringing the tale of Earth into the infinite darkness.